Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing Bedtime Astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. Are we living in a cosmic simulation? The simulated universe hypothesis, a concept that hovers at the boundary of science fiction and philosophical speculation, posits that our reality, including the Earth, the cosmos, and even our very selves, could be part of a highly advanced computer simulation. This hypothesis has garnered serious attention from philosophers, physicists, and computer scientists alike, challenging our understanding of existence, consciousness, and the nature of reality itself. To fully appreciate the breadth and depth of this hypothesis, one must delve into its origins, its implications, and the arguments both for and against its plausibility. The roots of the simulated universe hypothesis can be traced back to ancient philosophical inquiries about the nature of reality. Philosophers like Plato and Descartes pondered the idea that the world we perceive might not be the true reality. Plato's allegory of the cave, for instance, describes prisoners who see only shadows of objects and believe those shadows constitute reality, while Descartes' skepticism led him to doubt the evidence of his senses, proposing that an evil demon could be deceiving him about the nature of the world. The potential ethical implications of the simulated universe hypothesis are also significant. If our reality is a simulation, what responsibilities do the simulators have towards us? Are they obligated to ensure our well-being and prevent suffering, or are we merely expendable entities within a vast experimental framework? Conversely, if we ever develop the capability to create our own simulations, what ethical considerations should guide our actions? Should we treat the inhabitants of our simulations as sentient beings deserving of moral consideration, or as mere constructs without intrinsic value? In exploring these questions, the simulated universe hypothesis serves as a powerful thought experiment, challenging our assumptions and expanding the horizons of our intellectual inquiry. It invites us to consider the possibility that our understanding of reality is far more complex and nuanced than we currently imagine. Whether or not we ever find definitive proof of the hypothesis, the exploration of its implications can deepen our appreciation for the mysteries of existence and the limits of human knowledge. The simulated universe reflects our innate desire to understand the nature of reality, pushing the boundaries of science, philosophy, and imagination. As we continue to grapple with the profound questions it raises, we are reminded of the enduring power of speculative inquiry to inspire wonder and drive the pursuit of knowledge. Whether we are living in a base reality or an intricate simulation, the journey of discovery itself is a testament to the richness and complexity of the human experience. Furthermore, there are philosophical objections to the simulated universe hypothesis. Some argue that it leads to a form of radical skepticism, undermining our confidence in empirical knowledge and scientific inquiry. If we cannot trust our perceptions and experiences to reflect an objective reality, then the foundations of science and philosophy are called into question. Others contend that the hypothesis is unfalsifiable and therefore falls outside the realm of scientific inquiry. If no possible observation could ever disprove the hypothesis, then it becomes more of a speculative metaphysical proposition rather than a scientific theory. Despite these challenges, the simulated universe hypothesis continues to captivate the imagination of both scientists and the general public. Its implications for our understanding of reality, consciousness, and the nature of existence are profound and far-reaching. If we are indeed living in a simulation, it raises fundamental questions about the nature of the simulators and their motivations. Are they advanced descendants of humanity running simulations of their ancestors for research or entertainment purposes? Or are they entirely alien beings with incomprehensible goals? Moreover, the hypothesis forces us to reconsider the nature of consciousness and free will. If our minds and experiences are the product of a simulation, then what does that imply about the nature of self-awareness and agency? Are we merely sophisticated programs running within a vast computational framework, or do we possess some form of intrinsic, non-simulated consciousness that transcends the digital substrate? Despite these compelling arguments, there are significant challenges and counterarguments to the simulated universe hypothesis. One major criticism is the sheer computational power required to simulate an entire universe with such fidelity. Simulating the vast number of particles and interactions in the observable universe, not to mention the consciousness and subjective experiences of sentient beings, would require an astronomical amount of processing power and energy, potentially beyond the capabilities of any conceivable civilization. However, proponents counter this by suggesting that not every detail of the universe needs to be simulated at all times. Instead, the simulation could employ a form of optimization, rendering details only when they are observed or interacted with, similar to how video games render scenes dynamically. This approach could drastically reduce the computational load, making the simulation more feasible. Another significant challenge is the problem of detection. If we are indeed living in a highly sophisticated simulation, how could we ever prove it? Any anomalies or glitches in the simulation could be subtle and easily explained away as observational errors or limitations in our current scientific understanding. Some theorists have proposed that we might be able to detect signs of the underlying computational structure through careful analysis of physical phenomena, such as the behavior of particles at the quantum level or the distribution of cosmic background radiation. However, definitive evidence remains elusive. One of the most compelling arguments in favor of the simulated universe hypothesis is the rapid advancement of computer technology. Moore's law, which observes that the number of transistors on a microchip doubles approximately every 2 years, leading to exponential increases in computing power, suggests that future civilizations could develop computers capable of running extremely detailed and realistic simulations. We already see early examples of this in the form of video games and virtual reality, where entire worlds with complex physical laws and autonomous characters are created. Moreover, as our understanding of quantum mechanics and the nature of computation deepens, the concept of a universe governed by informational processes becomes increasingly plausible. Some physicists, like John Wheeler, have proposed it from bit doctrine, suggesting that information is fundamental to the physics of the universe. This perspective aligns well with the idea of a simulated universe, where the fundamental building blocks of reality are not particles or fields, but bits of information processed by an underlying computational substrate. Another intriguing argument for the simulated universe hypothesis arises from the apparent fine-tuning of the universe. The fundamental constants of nature, such as the gravitational constant and the cosmological constant, appear to be precisely set to allow for the existence of life. Some proponents of the hypothesis suggest that this fine-tuning might be evidence of a design simulation, created with the specific intent of fostering life and consciousness. In the modern era, the hypothesis took a more formal shape with the advent of computer technology and digital simulations. The idea gained significant traction in 2003 when philosopher Nick Bostrom published his influential paper, "Are You Living in a Computer Simulation?" Bostrom's argument is structured around a trilemma, suggesting that one of the following propositions must be true. 1. Almost all civilizations at our level of technological development go extinct before becoming technologically mature. 2. The fraction of technologically mature civilizations that are interested in running ancestor simulations is almost zero. Or 3. We are almost certainly living in a computer simulation. Bostrom's trilemma hinges on the concept of ancestor simulations, hypothetical detailed simulations of forebears that an advanced civilization might run. If such civilizations reach a point where they can create highly sophisticated simulations that are indistinguishable from reality, and if they are inclined to do so, then the number of simulated realities could vastly outnumber the one base reality. Hence, the probability that we are living in one of these numerous simulations would be extremely high.